Hey everyone, and welcome to our stainless steel pipe factory. Have you ever wondered how the shiny, durable pipes used everywhere from your kitchen sink to massive industrial plants are made? Today, we're pulling back the curtain to show you the complete journey, transforming ordinary steel coils into one of the most vital materials in modern industry. It's a fascinating process full of incredible engineering. Ready? Let's dive in. Our journey begins with these massive stainless steel coils. Think of them as giant rolls of high-quality steel tape. The most common grades we use are 304 and 316, prized for their excellent corrosion, resistance, and durability. Each of these heavy coils is carefully loaded onto a decoiler. This machine acts like a giant spool holder, slowly and steadily unwinding the steel coil into a flat strip, feeding it directly onto the production line. Once unwound, the steel strip moves to the slitting machine. Here, incredibly sharp rotary knives cut the wide coil into narrower strips. The width of these strips is a critical parameter. It's calculated precisely based on the final diameter of the pipe we want to produce. Accuracy here is everything. Even a 1 mm deviation might seem tiny, but it can completely ruin the final pipe, leading to defects in shape or welding. So, this first step sets the foundation for the entire process. With the strips cut to the perfect width, they now enter the heart of the factory, the pipe-forming mill. This is where the magic of transformation truly begins. The flat steel strip glides through a long series of rollers. Each set of rollers is meticulously angled to gradually bend and shape the strip. It's not a one-step process. It's a gentle, progressive curving. The strip starts flat, then becomes slightly U-shaped, and then more C-shaped, until finally, the two edges meet perfectly at the top, forming a hollow tube. Whether we're making a round, square, or rectangular pipe, this forming stage is what gives the pipe its fundamental shape, all before a single weld is made. The seam is now perfectly aligned, ready for the next crucial step. Now that we have a perfectly formed but unsealed tube, it's time to fuse it together. The tube moves seamlessly into the automatic TIG welding station. TIG stands for tungsten inert gas. A high-frequency electric arc melts the two edges of the steel strip, fusing them into a single, incredibly strong seam. During this process, an inert gas, usually argon, is used to shield the weld area from oxygen and other atmospheric gases. This prevents oxidation and ensures a clean, non-porous, and highly corrosion-resistant weld. To guarantee perfection, high-speed cameras and sensors monitor the weld seam in real time, checking for any inconsistencies or defects. This automated precision ensures every inch of the pipe is flawlessly joined. After welding, the pipe is strong, but the intense heat from the welding process has altered the steel's internal structure right around the seam. To fix this, the pipe immediately undergoes annealing. It passes through an induction heating furnace, where it's heated to over 1000 degrees Celsius. This high-temperature treatment realigns the steel's crystal structure and, most importantly, redistributes the chromium evenly. This restores the pipe's full strength and its signature corrosion resistance across the entire surface, including the weld. Immediately after heating, the glowing hot pipe passes through a water cooling system, which rapidly cools it down, locking in the improved properties. The pipe now has its strength back, but the heat from welding and annealing has left behind a discolored oxide layer, often called heat tint, especially around the weld seam. To get that signature clean, uniform stainless steel finish, the pipe goes for a chemical bath in a process called pickling. It's submerged in a special acid solution that dissolves the oxide layers, surface impurities, and any residues from the welding process. This step is vital for applications where hygiene and purity are critical, as it ensures the entire surface is pure, passive stainless steel, free from any contaminants that could later cause corrosion. Safety is paramount here, with all chemicals handled in a controlled environment. With the pipe chemically cleaned, it's time to make it shine. The pipe moves to the polishing station. Here, it passes through a series of rotating polishing belts or wheels coated with abrasive compounds. This is a multi-stage process. It starts with coarser grits to remove any surface imperfections and gradually moves to finer and finer grits. This isn't just for looks. In industries like food processing, pharmaceuticals, and biotechnology, A highly polished, crevice-free surface is essential to prevent bacterial growth and ensure easy cleaning. At this point, our pipe is looking great, but it might have developed some slight bends or curves during the heating, cooling, and handling processes. To ensure it's perfectly straight, it goes through a straightening machine. This machine uses a set of carefully arranged rollers that apply precise pressure to correct any deviation, making the pipe perfectly linear from end to end. Right after straightening, it passes through a final set of sizing rollers. These rollers perform a final calibration, ensuring the outer diameter of the pipe meets the exact specifications required by the customer, with incredibly tight tolerances. Quality is not just a goal, it's a requirement. Before any pipe can be cleared for shipping, it undergoes a rigorous battery of tests. First is the hydrostatic pressure test, where the pipe is filled with water and pressurized to a level far beyond its normal operating conditions to check for any leaks or weak spots in the weld. Next, it undergoes non-destructive testing. The eddy current test uses electromagnetic fields to detect tiny surface defects, while the ultrasonic test sends sound waves through the pipe wall to find any internal flaws. Finally, there's a thorough visual inspection and a dimensional accuracy check with calipers and micrometers. Only the pipes that pass every single one of these stringent tests are allowed to move on to the final stage. We've made it to the finish line. The quality-approved pipes, which are still in one continuous long piece, are now fed into high-speed cutting machines. These machines use sharp blades or abrasive discs to cut the pipes into standard or custom-ordered lengths with clean, burr-free edges. The finished pipes are then carefully bundled together, often with plastic wrapping or wooden crates, to protect their polished surfaces during transit. Each bundle is labeled with its grade, dimensions, and production batch for full traceability. They are now ready for shipment, heading out to construction sites, food processing plants, oil refineries, and countless other destinations around the world. And there you have it, from a humble coil of steel to a finished high-performance product. The creation of stainless steel pipes is a perfect symphony of raw power and delicate precision, blending advanced machinery, meticulous engineering, and fully automated quality control. It's a process that ensures every pipe that leaves this factory is ready to perform its vital role in our modern world. Thanks so much for joining us on this tour. If you enjoyed seeing how things are made, make sure to like, share, and subscribe for more deep dives into the world of manufacturing and factory processes. See you in the next video.